In example 3, we're going to consider the distributions with their given mean and standard deviation. We have 3 of them here, so they're a little bit hard to read. Here the mean is 3. Hopefully you can see that there at home or wherever you're listening or watching this video. Standard deviation is 0.5. So the mean we say is this symbol right here. So the mean, it's a lowercase Greek letter m. The mean for this one is 3 if you can't see that, and the standard deviation is 0.5. For the next one, the mean is also 3, but the standard deviation is 1. And that's mu there, and that means the mean. So we've got 3, and then standard deviation is 1. For the next one down here, the mean is still 3. That's this part right here. And the standard deviation is now 0.25. That's that part here. Let's look at part A. It says, how does standard deviation affect the shape of a frequency distribution? Well, if we take a look at this first one here, the mean is right in the middle. As a matter of fact, the mean is in the middle of all of these. So that's a value of 3. It's super hard to see the scale. You'll just have to trust me that that value is 3. That's the mean right in the middle. So what does the standard deviation do? Well, if we look at this graph right here is our reference with a standard deviation of 0.5. When the standard deviation increases, it looks like less of the data. So we're looking at this guy right now. Less of the data is towards the middle, and it's more spread out. What about when the standard deviation is lower, like this graph here? Well, more of the data is clustered closely to the mean, and less of the data is spread out. So it seems as if the change in standard deviation affects how spread out the data is. Okay. And we could also say let's see, higher standard deviation means it is spread out more. We should say the data is. Let's be more specific with that, I guess. So higher standard deviation means data is spread out more. Okay. Why does it have that effect? Well, that's a silly question. I think C part A, that's what standard deviation means. It's how far the data is spread out. So the higher the number, that would be a larger spread. So I guess we could say that the number corresponds to, so standard deviation corresponds to how the data is spread out. Higher numbers mean the data is more spread out, and lower numbers mean that the data is less spread out, indicating that the lower the standard deviation is, the more data is closely centered around the mean.